Alright, so we are going to work through glycolysis, and for glycolysis we're going to start with glucose as our substrate that we're going to break down. And remember, the formula for glucose is C6H12O6, and we're going to count carbons throughout. So it's good to remember that we're starting with a 6-carbon molecule. The next step here is to prime the pump, get things started. And so in order to do that, we need to put in some energy. And of course, we are going to use ATP as our energy carrier. So we'll break off a phosphate during that process to get ADP, adenosine diphosphate, and an inorganic phosphate. We still have a C6 molecule at this point. Okay, we're going to continue to put energy into this reaction to help get things rolling. And so again, we're going to break off a phosphate from ATP, adenosine triphosphate, to create ADP and that inorganic phosphate. Okay, at this point, once we energize it this much, this molecule becomes really unstable and immediately breaks up into 2 C3 compounds. This C3 compound is known as PGAL for short, 3-phosphoglyceraldehyde. You may have also heard it referred to as G3P. Okay. I'm bringing that up because we will revisit that compound later on. Now, it's time to strip some electrons out, and we'll use those electrons later. The electron carrier that we're using is NAD+, and when we pick those electrons up, we're also going to pick up a proton to give us NADH. So I'm showing 2 arrows here because that is going to happen for both of those C3 molecules. Alright, so now we have our 2 NADH electron carriers. We'll see that we use those later on. And now we're going to finally get some energy out, right? The whole purpose of respiration is to get energy out. So we did get some out and put it into that electron carrier as energetic electrons. But now what we're going to do is we're going to do some rearranging. Okay, and we're finally going to get some energy out and stick on a phosphate to ADP to form ATP, and we'll use that elsewhere in the body, in the cell, to do other reactions, whatever's necessary for the cell to keep on ticking. And once we get that energy out, the C3 compound that's then formed is referred to as PGA, phosphoglyceraldehyde. We also get out a water molecule. It's often not included with our products because what's going to happen later on, we'll see, is that we're going to use that water and put it back into this process. We still have a C3 molecule here as we're rearranging for each side. We're going to get more energy out and stick that energy into ATP. So stick a phosphate on, store that energy away in that bond. And then at the end of that step, we have still a C3 molecule, but this C3 molecule we're going to refer to as pyruvate. The C3 molecule at this point has a potential for several fates. It could go into a fermentation process to recover NADH, or it could go into aerobic respiration, which requires oxygen, whereas if it goes into the fermentation pathway, that does not require oxygen. Okay. One other thing that I want to mention is when we are producing ATP in this process, that's here. We have 1, 2, 3, 4 molecules of ATP being produced. That happens under substrate level phosphorylation. And that simply means that we're going to use an enzyme to construct ATP here. And that ends our discussion of glycolysis, which occurs in the cytoplasm of our key bacteria and eukaryotes.